Greetings, this is Paul Jensen, and I'm here to present a lecture which is part of Chapter 4, Critical Parameters for the Installation of UVC Luminaires. And this has been presented at the 15 August 2023 NALMCO Germicidal UVC Training and Certification course that was presented at the University of Maryland and funded through the Baldy Foundation. Now, when we talk about this topic, we must first think about safety. So safety, we're not talking about ultraviolet germicidal irradiation. We're talking about general safety. And what do you see here? We always have to think about safety. Here's obviously somebody standing on a ladder, reaching out to touch some wires in a box to splice in the fixture that you see in the background. So where do we start? First, we'll start with reviewing layout design. Was the layout design seem reasonable? We'll walk through the facility and ensure that there are no obstructions or other reasons not to install as designed, and contact the designer to discuss any deviations from the design. So what would you find as a potential deviation? Well, maybe they had architectural features suspended from the ceiling, so you can't really irradiate the whole portion of the upper room. So you may have to redesign the fixture type. Perhaps there are some beams or other items such as ventilation ducts, signs, parts of walls that aren't on the diagram itself that could impede or stop the UV from reaching its full potential across the room. And also verify that electrical services are there. The services needed are not huge, but it would be preferable to have the UVC luminaires wired to a branch which only includes the UVC luminaires. So what do you see here? This is a diagram of iso-irradiance lines. So if we take a look at the center line, this is the output from a fixture. So it's essentially in a very high ceiling room, and this is one with a 20-foot ceiling. We would measure 10 microwatts per square centimeter at the edge of this plume or iso-irradiance line. With the red line, obviously it's going to be much, much higher. And with the green line, it's going to be much, much less. So between here, which is the blue, and the edge of the green would be essentially ranging from 10 down to 1 microwatt per square centimeter. Why is that important to understand? Well, we also have to understand the horizontal distance. In this case, it's 35 feet. So we find that 1 microwatt per square centimeter will meet or reach the far side of the room or within a foot of it. We'd also want to take a look at the plan view or looking down from the ceiling. How far does it spread? We want to have relatively uniform coverage. And when we go into Chapter 8, we'll talk about that a little bit more. So here's a different fixture and a different set of isopleths. But you can see that this one is relatively uniform and let's call it skinny number of isopleths or iso-irradiance lines. What happens if we have, and I'll just use an example of an 8-foot ceiling. versus a 10-foot ceiling. So here we've installed the unit 7 feet from the bottom of the fixture down to the floor. So from 7 feet to 10 feet, we have 3 feet of volume that we can irradiate. If we have our ventilation system, which is sort of the standard 4-way diffusers in the ceiling, what happens? Well, we've got clean air coming in, so any air that's irradiated that's coming in, you're not really irradiating air from the occupied space. So you don't have organisms being disinfected, inactivated, killed in the irradiated zone that's adversely affected by the clean air coming into the room. Now let's take a look at an example of this. So here's the same ventilation system, but an 8-foot ceiling. So you've got clean air coming in here, and what we see is that we're irradiating clean air, so not all of the UV that's coming out of this fixture is actually irradiating air that comes up from the occupied space. What about fixtures that point downward? Well, that's also quite interesting, because you're going to have the same issue that the upper part of that irradiation is not going to be effectively irradiating organisms from the occupied space. So let's go again. Where do we start? Well, the luminaires. We want to verify that the luminaires meet the specifications in the layout design. Why? Were the fixtures that were specified in the layout the same make and model of fixtures that you received? Verify that luminaires are assembled correctly. There should be some simple instructions of how things are. Is there a reflector in the back that's loose and bouncing around? Verify that the luminaires are operational. Now, don't look into it. We've talked about safety earlier in this course, but you can always point it towards a wall away from people, and with your meter, just verify that it's 254 nanometer wavelength coming out of a low pressure mercury, that it's 222 nanometer wavelength coming out of a CARE 222 or other excimer lamp system, or if you have luminaires with UV LEDs, what do? You just set your meter for whatever wavelength LED you have and verify that you've got that coming out. Quite often manufacturers will give you the minimum irradiance at 1 meter or 3 feet from the fixture. So you're looking a meter or 3 feet from the fixture, and what's the maximum reading we have? We may have to actually move the detector vertically to find where that maximum is. It's important to review the manufacturer's installation instructions. So here we've opened up the fixture, and what are we doing? Well, we're just making sure everything is there secure. And then we also take a look, is everything clean? Here's the reflector, and this was as received from the company. It has a bunch of dust particles, perhaps from the cardboard shipping container. It's very difficult to say exactly what it's from. So quite often, part of the initial evaluation of the fixture, one would also do an initial cleaning of the fixture. And we talk about that process in a bit. Let's go back to where do we start? Ensure you have the following tasks at hand. Do you have the collection of appropriate tools? Do you have the materials to install, and we'll say hang or wire, the fixtures or luminaires? Do we have the cleaning supplies available? Do we have a calibrated radiometer and detector and some type of measurement stand? And as you heard from Dr. Sliney earlier, The standard eye height measurement is taken at 1.8 meters or roughly 6 feet. Minimum toolkit and supplies. And this is just a starting point. You may have additional tools and whatnot, but you need a ladder that's OSHA compliant. You don't want to use one of these cheapo aluminum ladders that sort of wiggles when you open it up. We want an OSHA compliant ladder. Whenever I'm in the upper room space or near a UVC luminaire, I'll always wear glasses. If I'm going to have to touch the lamp or LED surface, then I would also wear gloves so I don't leave hand oil on the surfaces. For installation purposes, you need some kind of a drill and assorted bits, drywall, concrete, wood, metal. So you may not know what exactly you're hanging it to until you actually get there. Some plans are very good at identifying it, some are not. Screwdrivers, nut drivers, pliers, level, tape and or laser measure, and anchors to make sure that meaning the UVC luminaire, is secure to the wall, ceiling, or other surface. So here's somebody, he's got his safety glasses on. This was during the beginning of COVID, and he's opening up the fixture. This outlet is on a switch, so he turned off the switch and put painter's tape over top of it and marked, well, he marked leave off, but it's not quite the official OSHA lockout tagout, but it's good enough. And ideally, he could have just unplugged it as a second safety features, and then that way if somebody did play with this switch, it would not perhaps expose him. Now, once you take the cover out, most UVC luminaires have a safety switch so the lamp will go out. And if that switch is working, then it's perfectly fine. So anyway, he's standing actually on a desk. He used a sturdy ladder to climb up onto the desk and is now removing the louvers from this fixture. To continue with minimum toolkit and supplies, for electrical modifications, we need to make sure we have wire strippers, snips, wire splicing connectors, or wagos, depending on how you pronounce it. And we also have to understand that there's certain electrical jobs that can be done in-house. There are certain electrical jobs that you might need to hire somebody to do. And in some cases, you're dealing with a union worker or company versus a non-union worker or company. Cleaning supplies, ideally lint or dust-free gloves, lint-free cloth or towel, or sometimes cotton balls. You need a solution that's greater than 70% alcohol, and no surfactants or soap. There are some alcohols that also have a surfactant soap in it. We do not want that because that will leave a residual on the surface of the lamp. I often use a paintbrush to clean louvers, and occasionally reverted to vacuuming out the louvers because they were so dirty. It's critical, as I mentioned earlier, about having the proper UVC meter. And this will be discussed in Chapter 7, so I will not go into much detail other than the two companies that I'm aware of that make high quality UV meters are International Light Technologies and Gigahertz Optic. Both of them have their main offices in the outskirts of Boston, Massachusetts. So let's get started. UV methods for luminaires. Well, you may have a wall-mounted luminaire. You could have a ceiling mounted onto a hard surface ceiling. You may have ceiling suspended. So if you have a suspended ceiling or drop ceiling with either like a 2 foot by 2 foot or 2 foot by 4 foot acoustic tiles dropped in, you'll need to do a different kind of installation than a ceiling mounted. And then in some cases, you might do a tripod mounted fixture that would be more on a temporary basis. So wall mounted UVC luminaires. Here you can see somebody actually drilling holes into a concrete wall. And depending on what matrix the wall is, you'll have different kinds of anchors. And again, I'm not going to say one anchor is better than another, but it's something to make sure you have the best possible. Level. I said bring a level. Where can you find a level? Quite often you can find one on your phone. There are many different apps for levels. And what we're doing here is this is a bubble level. So when I do an installation, I try to set the fixture so that the fixture, not the louvers, but the fixture itself is parallel to the ground. And then if we need to adjust it up or down, we can. But to have a uniform starting point, that's where we start. So here's the picture of the, in this case, iPhone level on top of the UVC luminaire, and you can see the bubble is right in the middle. So the fixture, not the louvers in this case, but the fixture is plumb to the earth. Now, in an earlier picture, you saw somebody, actually this fella, drilling holes into this cement wall. So these are wall-mounted UVC luminaires. Here you have ceiling suspended UVC luminaires. So if we take a look here, there's 3/8 inch rod from this bracket all the way up to this high space above the drop ceiling, and using standard clips. So it's relatively easy to do, but you'd need a professional to do it and do it right. So here's a very high ceiling room, or used to be a lobby and is just a smaller lobby, in which they added restrooms and offices to part of it. So part of this area has very high ceilings, and part of it has a space above this area that could be irradiated, but there's not sufficient space underneath here to use any kind of 254 upper room UVC luminaire. Ceiling suspended UVC luminaires. This particular unit fits into a 2 foot by 2 foot square of a drop ceiling or a suspended ceiling. And you really don't need much in the way of additional support. Some suspended ceilings may not be secured very well, so you really have to take a look at what's up there. Very worst cases, you might have to add a couple extra wires to secure the track a little bit more. My previous slide had a 254 unit. This slide actually has 222 units in the top that are actually shining straight down as opposed to shining parallel to the floor. There are different manufacturers of these units, but they all use the same basic technology that Rolf talked about earlier. You may have a tripod mounted luminaire. In the case here, the left one is a 222 and the right one is a 254 louvered fixture. This was done temporarily for this one particular conference. So tripods are an option, not just for this 222 unit, which comes with a tripod, but also for 254 units. Electrical connection must be decided as part of the design development. Are the fixtures going to be hardwired, or are they going to be plug-in outlet. Will that outlet be switched or unswitched? Will it be switched at the location, which in this case it's a keyed switch? Will it be at the breaker box or somewhere in between? And obviously we have to follow local and national electric codes. Let's talk about preliminary safety testing. We start again by gathering the manufacturer's information, their installation, operation, maintenance manuals. Make sure we understand what wavelength or lengths are emitted from the UVC luminaire. You need to have a radiometer calibrated to the wavelength or wavelengths of interest. Generally, meters are calibrated every year. I often calibrate them every 2 years, but I stagger them. So I always have 1 meter that's within 1 year of calibration. If there starts to be significant deviation between the two, then I will need to send them back in for testing and calibration. I often, but not always, use an 80-degree field of view cone, which is level plus or minus 40 degrees, and Dave Sliney talked about that in an earlier presentation. Why do we use that? It's to simulate your eyelid and your eye socket, because not all the light is hitting your eye. Then we need some type of measurement device. I initially take gross measurements to determine average irradiance, generally within occupant exposure guidelines. The output of luminaire within specifications of the manufacturer and provided by an in situ test specification. Often manufacturers will give an irradiance measurement at 1 meter or 3.3 feet from the luminaire. Warm up and burn in the lamps. It generally doesn't take very long. In the olden days, it was considered 100 hours before the low pressure mercury lamps reach equilibrium, but nowadays it's much shorter than that. If the manufacturer does not give a recommendation, then allow them at least 15 minutes to warm up. Burn in the lamps per manufacturer's recommendation. Absent that, allow at least 1 hour for the UVC lamps to burn in and reach equilibrium. Time for temperature stabilization with LEDs should also be considered. Then we'll do the preliminary adjustment, upper room UVC luminaire for a single space. And I'll talk about a multi-unit space. But for a single space, we'll place the UVC detector on a tripod, pole, or other device, 1.8 meters or roughly 6 feet above the finished floor. And this is the 99th percentile eye height for U.S. males standing. Place the 80-degree field of view cone on the detector and orient the detector so that it is measuring UVC parallel to the floor. Lay a tape measure on the floor, or if you use a laser measure, you can put painter's tape to mark the spots. And this would be straight out from the fixture and perpendicular to the fixture. So I'll show that in a future slide. So here's a pole. It's hard to see, but behind this black tape, we have the detector. Here's the meter. And what are we measuring on the meter? 0.71 microwatts per square centimeter. Is that safe or not so safe? This is the reading we received after we installed all 5 fixtures in this room and turned them on. So 0.71 is a little bit high, but where it's taken, which is not at the bed, it's not at an area where somebody would stand for 8 hours and stare at the fixture. So yes, it's a little high, but it's not totally alarming. We did do adjustments to get it down to about 0.4 microwatts per square centimeter. And the 8-hour time-weighted average, assuming a 6,000 microjoule per square centimeter dose, would give us, by just some simple math, 0.21 microwatts per square centimeter. So when we're doing the installation, it's okay to be above that as long as people won't be there for 8 hours and staring at the lamp. So here's somebody doing a preliminary adjustment. You can see it's a relatively narrow beam. He's got his tape measure on the floor. So we'll take your irradiance measurements generally in 2-foot increments. If you have, tile that's, 1 foot, or say it's 18 inches, whatever, you can use the tile on the floor for your grid as well, because it doesn't necessarily have to be the exact 2-foot increments, but it's whatever is convenient. Take additional measurements when pointing the detector at the luminaire as well as other surfaces looking for reflection. So I want to see, okay, am I getting a lot of reflection off the ceiling, or perhaps some galvanized ductwork or something else? Critical is knowing what the meter is telling you or showing you. Is it showing you total irradiance or weighted irradiance? And when Rolf speaks about meters, and I think it might be Dave Sliney sometimes talks about meters, they'll discuss what the difference is between total and weighted irradiance. So generally I use 2 times the 8-hour UVC 254 dose. Earlier I mentioned 6,000 microjoules per square centimeter, and that's the peak at 270 nanometers. So if we're talking about the weighted dose, we're talking about 3,000 microjoules per square centimeter, convert to a constant irradiance of 0.2 microwatts per square centimeter. So this is why it's important to understand what is the meter reading or presenting to you. Criteria may vary based on risk assessment. If it's a high risk area, maybe you go a little bit above the 0.2. Like I mentioned in the previous bullet, I'll go up to 0.4, occasionally 0.5 if it's a high risk area, and I'm certain that nobody would be standing there staring at the lamp for 8 hours. UVC design parameters are also a criterion, that in some rooms you may not be able to get the exposure low enough because the room is so small or so much reflection that you might have to either change the fixture design or do something else to reduce that reflection. Now let's talk about multi-unit spaces. So there's more than one upper room UVC luminaire. It's a little more difficult as the 2 luminaires result in some overlap or some additive effects of the 2 luminaires. What I'll do is I'll repeat the measurements described above for a single unit space for each luminaire with the other luminaires turned off. And I'll use the criterion of 1 times the TLV, or in the case of 254, it would be the 0.1 microwatts per square centimeter for 8 hours. I'll also tilt the meter up and down a little bit to see, if something funky is happening in terms of reflection. The next step is to repeat the measurements with all the luminaires operational. And now I'll go back to what I used for the single luminaire space, and that's my criterion, which will include the overlap or the additive effects of different fixtures. And based on the 0.2 times 2, or 0.4 microwatts per square centimeter, again for 254 nanometer, we'll make the necessary adjustments to the luminaires. Maybe tilt the louvers or the fixture up or down. Some might have a reflector that's adjustable. But again, we just want to make sure that we have a safe environment. So here are people taking, actually the same people are taking readings before, but they're taking readings on a pole at roughly 6 feet, and they're recording the numbers on their notes. So let's take a look at this room. What do you see here that could hamper the installation of UV and that might not be on a plan? Well, we know it's a drop ceiling. What is this? This is a ventilation duct or supply air duct. If we have UV, at the 7 foot above the ground, will that UV be blocked by some of this duct? Probably yes. Would you want to install them above the TV? Well, no, for two reasons. One is the duct could block some of the UV. And secondly, if these get misadjusted in between times in which you test it, and it gets misadjusted down, then there's potential for overexposing people because they may spend 4 to 6 hours, in this case it's homeless shelter, watching TV. So what was the solution? Well, the solution was on this wall, we put a 254 nanometer fixture. You can see some of the blue glow. That's not the UV. That's the extraneous blue wavelength coming out of the fixture. And then not on this wall, but the wall towards the camera, we put the other fixture. So we've got UVC being towards me here, and then on the other side would be away from me. So preliminary adjustment. The whole room, we place the detector on a tripod, same thing, 1.8 meters, 6 feet above the finished floor. Use the field of view cone, usually lay a tape measure down, or again, mark the location with painter's tape. And I take measurements in 4 cardinal directions, meaning that I may point it directly at the fixture, 90 degrees to the right, directly opposite, and then 90 degrees to the left of the fixture. When we're dealing with a whole room or direct irradiation UVC luminaire, it's a little bit different also. We take irradiance measurements directly below the luminaire, and generally in 2 foot increments in each cardinal direction. We'll take additional measurements while pointing the detector at the luminaire as well as at other surfaces looking for reflection. And measure in a grid if the device is not perpendicular to the floor. When we're talking about a multi-unit space, and again, we're talking about whole room or direct irradiation, it also is a little more difficult because of overlap. We repeat the measurements described in the single unit for each luminaire with only one of them on at any one time, and use the simple evaluation criteria of the TLV for an 8-hour continuous exposure. And then we do our preliminary adjustment, and we'll have all the luminaires on, and we'll use the evaluation criterion, which is twice that of the TLV. So here's a little example. On the left is a picture of a Sergio Bernales Hospital in Peru. The picture on the right is Hipólito Unanue Hospital in Peru. Both of these were older buildings. Both of these were designed very nicely for natural ventilation, but over time there have been changes. In this case, we have a small building added to an existing building, and on the left is an examination room, on the right is an examination room, and in the middle is a waiting area. How much ventilation is in this waiting area? Well, there are no windows, there's just a set of doors here, so there's actually a very small amount of natural ventilation. So there was a need to do some supplemental enhancement of the room, and in this case, the decision was made to use or consider to use upper room UVC. So here you can see the room itself. It has relatively high ceilings. There is a cupola type ridge vent that's partially open, so it does allow for some convective action. So air would move from the waiting area up to the top, but it may not be very, very fast. They have two cooling fans in the corners. So what we decided to do was we would install the UVC at roughly 7 feet above the floor, use these two fans continuously so we always have air mixing, and we've basically installed UV in a room which needed to inactivate or kill microorganisms and viruses in the air. Now, I apologize, this slide is upside down, but it was originally made the other way, and I presented it this way because I wanted to show what the irradiance levels were in relation to the original photograph. So the original photograph showed a fan on the left, a fan on the right, and we installed a UVC upper room UVC luminaire on the opposite wall. So each of these readings, so here's roughly a tile diagram. So these were 0.6 meters. So it's close to 2 feet, a little bit less. We went straight out, then we went to the right, straight out, to the right, straight out. So we actually have a 5x6 grid of readings. Because we had such a high ceiling and no obstructions, we were able to point this upwards and stay below even the exposure, the TLV exposure limit. So if we take a look at all these readings, the maximum was 0.13 microwatts per square centimeter. So it was perfectly safe for everybody in that room. But it was also unsafe for what might be aerosolized because the mixing fans will help move the air up into the irradiated zone and back again. Dave Slaney talked about spectral effectiveness. And when we take a look at, we'll just use 254 because that's what I was talking about initially. I used a factor of 2. So what does that mean? 2 is actually 1 over 0.5. So you can be exposed to more UVC, 254 wavelength, or actually twice as much as you could at 270, which has a factor of 1. That's important so that we understand what is the threshold limit value, or TLV, for different wavelengths. So if we look at the second graphic, or second table, we've got the same wavelengths, 222, 254, 265, 270. If we take a look at exposure limit for the eye, it's 3,000 for 270, it's 6,000 for 254, and it's 160,000 for 222. And then for skin, it's all the same for 254, 265, and 270. But for 222, it's 478,000 microjoules per square centimeter. So what does that mean in terms of microwatts per square centimeter? You can't really measure joules very easily unless you put a dosimeter on a person. But if we're just taking simple measurements with the radiometer, we could see that, okay, at 254 nanometers for the eye, the threshold limit value for that location staring at the fixture for all 8 hours and not moving, you need a irradiance level of 0.21 or less. When we talk about the skin for 254, it's 0.35 microwatts per square centimeter. For 222, it's 5.5 for the eye and 16.5 for the skin. So it's important to understand, what wavelength is the fixture putting out so that you can apply the correct criterion. Let's take a look at an example. This is a real life example. This is a dining hall at a homeless shelter. It was a multi-purpose homeless shelter. It had winter services, so when it got a certain temperature out, they'd open up some space for homeless people to come in to stay warm at night. It had some semi-permanent residents, had some short-term residents, and then it also had a meals program here. And for the meals program for the residents and for the community, they had a large cafeteria. You can see here it's roughly 54 by 42 feet. You can't see it, but there's large television on this wall to entertain people. So wintertime, the TV was on, and this was used for the cold weather area for homeless folks that are not residents. And then hallways were also used for the homeless. So the ceiling slopes from 24 feet down to 20 feet. And here's the picture. What do we have here? We have acoustic tiles. So that means we can't, when we're taking a look at the dosing and understanding UV, we need to see, okay, what is the height of these acoustic tiles? Well, based on that height, that's going to be our functional ceiling, not our physical ceiling, but our functional ceiling for UV. This question mark is where the TV is located. So what we decided to do was put in 5 fixtures. We didn't want to put one on the same side as the TV, but we could stagger them on opposing walls and put one on this wall. What does that do? Well, if we take a look at ISO irradiance lines, here they are for 1 fixture, 2 fixtures, and you can see there's some overlap here. 3 fixtures, oh, there's even more overlap here. 4 and 5. This looks super messy, but the highest amount of UV was in the center of the room. Lowest was in these corners. And we needed air mixing. So what did we do? We took a look at the ventilation system. It was strictly a 5-ton unit. Took a look at the ventilation system and had them operate the fans while the spaces were occupied. So the heating and cooling would cycle on and off, but the fans themselves will continue to move air, and that will be sufficient for getting enough air mixing. So is your head spinning? Mine certainly is. So what we have to remember is what? Rooms with multiple UVC luminaires are more difficult to adjust to ensure safe exposure levels in the occupied space. Now we have to think about what do we read in the literature, and even as recent as last month, there was a very negative article on UV, and we have to think about what are they actually saying. And let me just tell you a short story about death due to excess exposure to dihydrogen monoxide. Now we know about carbon monoxide, right? Carbon monoxide is one of the byproducts of incomplete combustion and can kill you. What's dihydrogen monoxide? Well, every year, and this is from the CDC website, there are 4,000 plus fatal unintentional drownings and 8,000 non-fatal drownings. So should we be worried about the chemical dihydrogen monoxide? No, but we need to be worried about the application of it. Lastly, from the standpoint of UVC dose, we want to make sure that we understand what Paracelsus told us way back in the late 1400s. That's what is there that is not a poison? All things are poison, and nothing is without poison. Solely the dose determines that a thing is not a poison. And in modern day times, this has been morphed into everything's a poison, but you can make it a non-poison at a low enough dose or a known dose. So in summary, what we've talked about here for the last 46 minutes is about installation. We want to make sure that the installation includes paying attention to details. The critical parameters, there are many more, are mounting of the UVC luminaires, electrical connection of the UVC luminaires, and the preliminary adjustments of the UVC luminaires. And during the practical exercise, you'll get to not necessarily do mounting or electrical work, though we'll show you mounting and electrical work, but we're going to talk about how to do preliminary adjustments. So on that note, let me end here, and if you have any questions about the certification program by NALCO, you feel free to contact Eric Ennen at the email here, or go to the NALMCO website, which is NALMCO, NALMCO.org. And you'll find some information about the certification program. So the training courses just give you the basic information. In order to be certified, you have to sit for a written test, then also for a practical test where we'll go through and evaluate your skills. You're taking measurements, doing adjustments, doing calculations, proper maintenance, and a few other items. Thank you very much. Have a great day.